Hello students, welcome to fourth lecture of chemistry in everyday life. So lastly we discussed about antiseptics and disinfectants, and today we are going to discuss about anti-fertility drugs. So antibiotics revolution has provided a long and healthy life to people because most of the disease which can kill a person comes from these type of microorganisms. So the life expectancy has almost doubled. That means in initial time when we do not have these type of antimicrobial or antibiotics, usually person live up to 45 years or 50 years, and now it is almost doubled because of these type of drugs. The increased population has caused many social problems in terms of food resources, environmental issues, employments, etc. To control these problems, population is required to be controlled. This has led to the concept of family planning. Anti-fertility drugs are used in this direction. So birth control pills essentially contains a mixture of synthetic estrogen and progesterone derivatives. Both of these compounds are hormones. So hormones are chemicals produced by specific type of glands inside the body which can do certain things. So these two hormones mentioned here, estrogen and progesterone, they are reproductive hormones. It is known that progesterone suppresses ovulation. Synthetic progesterone derivatives are more potent than the progesterone. Norethindrone is an example of synthetic progesterone derivative, most widely used as anti-fertility drug. The estrogen derivative which is used in the combination with the progesterone derivative is ethinylestradiol or novestrol. So structure of both are mentioned here. Now we are heading towards the second part of our unit, that means chemicals in food. So maybe you think which type of chemicals we are using as a food. So here is the list. So chemicals are added to food for their preservation, enhancing their appeal and adding nutritive values in them. Main categories of food additives are as follows. So food color, flavors and sweeteners, fat emulsifiers and stabilizing agents, flavor improvers or anti-stalling agents and bleaches, antioxidants, preservatives and nutritional supplements as minerals, vitamins and amino acids. So all of them are one type of chemicals, and some of them are known to us. As for example, vitamins and amino acids were already discussed in biomolecules unit. So now except for chemicals for category 7, that means minerals, vitamins and amino acids, none of the above additives have nutritive values. These are added either to increase the shelf life of the stored food or cosmetic purpose, that means to look good or to taste good. In their section we will discuss only sweeteners and fruit preservatives, that means which can give sweet taste and which can keep food for a longer shelf life. So first is artificial sweetening agents. Natural sweeteners, example sucrose, add to calories intake and therefore many people prefer to use artificial sweetener. So because of calorie you may gain weight or you may gain unnecessary contents inside the body. So that's why we have to move on artificial sweeteners. And one of the known name is saccharin, also known as orthosulfobenzamide, is the first popular artificial sweetening agent. It has been used as a sweetening agent over since it was discovered in 1879. Okay, so we are using it for a very long time. It is about 550 times as sweet as cane sugar. That means we can compare it like this way. 1 gram of this type of compound, that means saccharin, can give sweetness of 550 grams of cane sugar. It is excreted from the body in urine unchanged. That means when this compound passes through the body and when we excrete it or when we remove it from the body, it still has the same structure. It appears to be entirely inert and harmless when taken. Its use is of a great value to diabetic person and the people who need to control intake of calories. Some other commonly marketed artificial sweeteners are in given table 16.1. So here we have a table with three different categories: name of the artificial sweetener, structure and formula, and sweetness value in comparison to cane sugar. Cane sugar is widely used by us as a sweetening agent. So as a comparison, these values are mentioned. So simply we can compare it like this way. We have grams of the cane sugar mentioned here, and it is equal to the compound 1 gram of the compound. That means 100 gram of cane sugar gives sweetness equals to 1 gram of aspartame. Similarly, second we have saccharine. So as we discussed, 550 gram of cane sugar is equal to 1 gram of saccharine. Then we have sucralose, which is 600 times more sweet than the cane sugar. And then we have allium, which is 2000 times more sweet than the cane sugar. That means 2 kilograms of cane sugar gives equal taste or equal sweetening as the 1 gram of allium. Aspartame is the most successful and widely used artificial sweetener. It is roughly 100 times as sweet as cane sugar. It is a methyl ester of dipeptide formed from aspartic acid and phenylalanine. Use of aspartame is limited to cold food and soft drinks because it is unstable at cooking temperature. Now second, allium is a high potency sweetener. As mentioned, it is 2000 times more sweet than the cane sugar. Although it is more stable than the aspartame, the control of sweetness of food is difficult while using. So simple reason, if it is equal to 2 kilogram, 1 gram of allium is equal to 2 kilograms of sugar, that means minor quantity of allium can give comparatively high sweetness value. So that means if we add a very small amount, then still it can give more sweetness than the expected. That's why it is hard to control. Sucralose is trichloro-derivative of sucrose. Its appearance and taste are like sugar. It is stable at cooking temperature and it does not provide calories. Next we have food preservatives. So as the name suggests, it preserves the food. Food preservatives prevent spoilage of food due to the microbial growth. The most commonly used preservatives include table salt, sugar, vegetable oils, and sodium benzoate, C6H5COONA. So these are the chemicals which are being used inside the kitchen right now. Okay, we use salt, sugar, and oils to prevent spoilage of food. As for example, we can take the example of pickles. For example, mango pickles can be used for entire year. And what is the reason behind it? So simple reason, firstly we dip the mangoes inside the salt water. So as mentioned here, salt is a good food preservative. So it will prevent the action of microorganisms, and then we will dip those pickles or mango pieces inside the vegetable oil, and that's why they are away from the reach of microorganism and we can use them for entire year. Sodium benzoate is used in limited quantities and is metabolized in the body. Salt of the sorbic acid and propanoic acid are also used as preservatives. And last point in food category is antioxidants in food. So these are the important and necessary food additives. This helps in food preservations by retarding the action of oxygen on food. These are more reactive towards the oxygen than the food material which they are protecting. So simple thing is we are using higher reactive compound to prevent lower reactive compound. Just like metals, for the production of Fe, we often use block of zinc or magnesium because block of zinc or magnesium metals are highly reactive than the Fe metal. So as per example, to protect the Fe metal of the ships sailing inside the salty water of the sea, blocks of zinc or block of magnesiums are often placed at the bottom side of the ship because they are highly reactive. So first these blocks of metals will react with the salt water and that's why Fe will be protected, and when they are corroded or when they are consumed, then we will replace it with new blocks of metals. That's why we can keep the Fe metal safe. So similar situation is going on here. We are using more reactive compounds towards the oxygen for the prevention of food. So these are the examples mentioned here. The two most familiar antioxidants are butylated hydroxytoluene and butylated hydroxyanisole. The addition of BHA to butter increases its shelf life from months to years. So it is a very drastic change. Sometimes BHT and BHA along with the citric acids are added to produce more effect. Sulfur dioxide and sulfite are useful antioxidants for wines and beers, sugar syrups, and cut, peeled or dried fruits and the vegetables. Okay, so these are the uses of the chemicals in the food. And in the next lecture, we will discuss about the last point of the unit, cleansing agents. That means chemicals used for cleansing purpose.